2024 was the hottest year Earth has ever recorded. Then something strange happened. In 2025, global temperatures actually fell. So for a moment, it looked like the planet might finally be cooling down. But NASA's latest analysis tells a very different story. Because even after that drop, 2025 and 2023 were statistically tied, and both remained among the hottest years ever measured. So, if Earth cooled in 2025, why is the warming problem still getting worse? NASA released its latest global temperature analysis in January 2026. And the first thing to understand is what NASA actually measured. Scientists at NASA's Goddard Institute for Space Studies combined temperature observations from more than 25 zero-zoned weather stations around the world with measurements from ships, ocean buoys, and research stations in Antarctica. They then analyzed that enormous data set to estimate how Earth's surface temperature has changed over time. The result was striking. 2025 was cooler than 2024, but NASA calculated its global surface temperature at about 1.19 degrees Celsius above the 1951 to 1980 average. And because the difference between 2025 and 2023 was smaller than the uncertainty in the measurement, NASA considers the 2 years effectively tied. 2024 remains the hottest year in NASA's record, which stretches back to 1880. But that creates an obvious question. How can temperatures fall from a record year while the long-term warming trend continues? The answer is that Earth's temperature does not move upward like a perfectly straight line. It moves more like a staircase. Some years go up, some years go down. Natural climate patterns can temporarily push global temperatures higher or lower. One of the most important is El Niño, when unusually warm conditions develop in parts of the tropical Pacific. Its opposite, La Niña, can have a cooling influence on global average temperatures. That means a single year can be unusually hot or unusually cool without changing the direction of the longer trend. NASA has repeatedly emphasized this distinction. Short-term variability can move individual years around, while the underlying warming trend remains visible over much longer periods. And that's where the data gets interesting. Look beyond 2025. NASA says the 10 most recent years are the warmest 10 years in the entire record. That changes the way we should interpret the 2025 number. The important story is not that 2025 failed to break the previous record. The important story is where 2025 sits on the entire timeline. A cooler year today can still be dramatically warmer than the years that came before it. And this is not something NASA sees alone. Independent analyses from NOAA, Berkeley Earth, the UK Met Office, and Copernicus also placed 2025 among the 3 warmest years on record, even though their methods differ. Different datasets and different scientific groups are arriving at the same broad pattern, but that still leaves a deeper question. What is keeping the planet so warm? The clue is not only in the temperature records, it's in the atmosphere, carbon dioxide. CO2 is invisible. You cannot smell it, see it, or feel a change in it when you walk outside. But it plays a critical role in Earth's climate because it is a greenhouse gas. Greenhouse gases absorb and re-emit heat, helping keep energy from escaping directly into space. Without greenhouse gases, Earth would actually be far too cold for life as we know it. The problem is what happens when their concentration increases significantly. And NASA's latest Earth indicator currently lists atmospheric CO2 at approximately 429 parts per million, with the latest measurement dated July 2026. That number comes from the long-running atmospheric record measured at Mauna Loa in Hawaii. 429 parts per million does not sound like much. But parts per million simply means that out of every million molecules of dry air, about 429 are carbon dioxide, and NASA's data shows that atmospheric CO2 has risen sharply over the past century. Because CO2 traps heat, that increase has contributed to warming the planet. But Earth does not respond to that extra heat uniformly. Land generally warms faster than oceans. The oceans absorb enormous amounts of heat, while ice reflects sunlight that would otherwise be absorbed. The atmosphere moves heat around the planet, and ecosystems respond differently depending on where they are. That is why climate change does not mean every location becomes hotter every day. A city in the United States can experience an unusually cold winter, while another part of the world experiences extraordinary heat. Weather can fluctuate dramatically. Climate is the longer pattern underneath those fluctuations. And NASA's temperature record is showing that the long-term pattern has shifted. This is why the 2025 number matters. It was not another record-breaking year. It did not need to be. After 2024 became the hottest year on record, the fact that 2025 cooled slightly might sound reassuring. But NASA's analysis shows that the planet remained close to the top of the entire historical record, and that 2025 and 2023 were effectively tied within NASA's margin of error. So the contradiction we started with finally has an answer. Yes, Earth cooled in 2025, but cooling for 1 year is not the same thing as reversing a climate trend. The real signal is much quieter than a single record. It's the persistence. Year after year, the temperatures remain unusually high. The atmosphere continues to contain elevated concentrations of heat-trapping gases. And across different scientific data sets, the same long-term warming pattern keeps appearing. NASA did not suddenly discover that Earth is changing. Scientists have known that for decades. What NASA's latest analysis gives us is something more powerful. Another year of evidence showing exactly where that change stands right now. And perhaps that's the part worth remembering. The most important climate record is not always the year that breaks the record. Sometimes it's the year that almost does and still ends up near the top. Because when the planet can cool from its hottest year on record, and still remain among the hottest years humanity has ever measured. The question is no longer whether one particular year was unusual. The question is how much the baseline itself has changed. And that is what NASA's latest data is quietly revealing about Earth.